Well, good day. It's Charlie again. I thought I'd just do one final video for this build. I've just completed close to a 45-minute to a 50-minute QSO using this radio with a local ham, just looking at the on-air performance, just to see how things were going. That was certainly useful, and it sort of helped me to sort of cement my ideas of where I want to go to next. But before I talk about that, I'll just sort of talk about the final configuration of the push-pull amplifier in terms of where I got to. In the end, I did not use for the low power driver stage here the BD139s. For whatever reason, they just didn't perform very well, so in the end I elected to use another two 2N305 3s. They certainly worked a lot better, but what I did find, and it's probably not surprising, was that it's not a matched pair, and I could certainly notice that one of these was warmer than the other. So while the signal on the oscilloscope didn't look too bad, I think that it really wasn't finely tuned. So the next push-pull amplifier I'm going to build will be similar, but I might get a larger number of the 305.3s, use the meter to work out what the HFE is, and try and get a better matched pair before going any further. But this was my very first attempt of using a push-pull amplifier, and I certainly learnt a lot. It was actually quite interesting in the end. What did we use in here in the end? This here was a 4-to-1, so the input to the two 2N305 3s push-pull was a small binocular transformer, single turn leading into the bases for these two devices, and then the load for this ended up being 4 turns in the end. Seemed to give the best power transfer into here. Between the two 2N305 3s and the MRF 644s, this was 5-to-1 in the end. Initially started with 4-to-1, but 5-to-1 seemed to have the better performance. And then the output of those two MRF 644s was this device here, and that in the end turned out to be a turns ratio of 2-to-1, so a single turn on the collector side and then 2 turns on the output side, which was interesting because it didn't quite line up with the maths that I thought, but kind of sort of lined up with a lot of the material I've sort of read, where the theory is one thing, but until you actually get into experimenting and playing around, things changed. These two MRF 644s are designed to operate up in the UHF range, and certainly down the HF range they ran stone cold, and that particular QSO was at 7 megs on the 40 meter band, and quite happily pushing out a good sort of 20 odd watts. As expected, at the lower frequency down at 3.5 megs, they were collectively together producing quite happily a good 50 watts, and of course up at 14 megs significantly less. So yeah, interesting. I made no attempt from an experimenting point of view of having any kind of feedback to try and stabilize that gain across the HF range, nor did I have a compensation capacitor, typically around 1,000 picofarads sitting across the two collectors. I didn't have that either, so it was very much sort of just playing around and sort of experimenting. In the end, for the base current for the two MRF 644s, this is an LM317 in a constant current configuration, and then measured putting into the bases around 110 milliamps. through that adjustment there. This is a 4.7 k ohm resistor, and that in the end provided through the that diode there around 57 odd, as it turned out, 57 milliamps base current for the two 2N3053s. This toroid here is probably, well, I think it is too small for the application. While it didn't get very, very hot, it certainly got warm. I must admit, and I'll put my hand up right now, this is all new to me, and I'm certainly not an expert in this field, but certainly that's probably not right. And looking at other amplifiers in that sort of 50 odd watts plus range, these are significantly larger. So I think for the next push-pull amplifier I do will probably be maybe 4 single tube type toroids, 1, 2, then 3, 4 to make a binocular type arrangement, or a whole lot of smaller ones sort of glued together to make 2 tubes. So that's something for me to play around with on the next radio. That was fine, that RFC, there was certainly no problems with that one, nor that one there. Certainly no indications of the windings themselves. So again, I guess the windings overheating. It was just the losses inside the toroid. So something for me to look out for on the next build. Right, so what I think I want to do next, I'm going to take the learnings from this radio and use it for the next build. What I've decided to do, and it's something I've been wanting to do for quite some time, was to have a dedicated transmitter and a dedicated receiver strip. They will share the SI5351, so that'll provide signals for both the transmitter and the receiver, depending if it's on transmit or receive. But other than that, it'll be a dedicated transmitter and receiver. While this crystal filter worked, it's certainly fair to say it wasn't the best crystal filter in the world. The skirts weren't steep enough really to fully attenuate the carrier. While that long QSI I had here with a local friend didn't identify that carrier, I can certainly see it if I was to, which I have when I've monitored the signal using the SDR radio as a monitor. So what I'm going to do for the next build, which will be, like I say, the transmitter and the receiver, is to have 2 separate commercial filters. I've got a couple in the junk box which I can then dedicate for transmit and receive. That'll also mean that I won't have to have these relays to switch signals around the place, which would be good. And I'm just debating what I'm going to do in regards to mixers. Do I want to go for, say, the ADE ones or the SBL ones, or do I want to sort of go fully homebrew and identify another 4 sort of matched 4148 diodes, and then make another 2 homebrew mixers? I'm sort of in 2 minds about that. We'll see. The AGC certainly worked well. I'm just debating if I'm going to use that in the next radio or not. It was certainly effective. Maybe I'll redesign that and have a different style. Again, I'm just sort of thinking about ideas and thoughts about where I want to go to with the next one, but that was certainly okay. In terms of the oops, sorry, apologies there. As for the Arduino and the screen and the like, I'll probably stick with that for now, for something different, and then I'll finish off doing the software to actually have the 2 VFOs and the memory and the scan functions. Whatever, yeah, I just didn't get around to doing that, but that's just a long-term goal. I will put up a couple of videos about software, so the plan there will be to create some generic simplified software for driving the SI5351 as well as receiving signals from the encoder, and we'll run through maybe 1 or 2 videos sort of looking at how I do it. And as I said to Chris on the radio, it's the world according to me. It is not the right way. There are certainly much better ways of doing it, but it's a way that works for me and how I like to do things, and I just continue to do it over and over again. So we'll just run through that again, with the caveat that it is not the only way, it is not the best way, it is a way, and we'll go with that. What else were sort of some lessons from this radio? This arrangement here for the bandpass filter certainly very effective with the old open ear sort of capacitor here. It is a dog's breakfast, and again, sort of during this build and listening to 80, 40 and 20, it really did, for me personally, sort of hammered home my liking and my preference for 80 meters here in New Zealand. So the next build will be a monoband build, and it will be built for 80 meters. So apologies there for anybody who would like otherwise. That will allow me to clean this all up, and my thinking is to break open the CNC machine and to actually machine up a few more circuits for the likes of the bandpass filter, and perhaps even also for the IF amps. Come up with sort of a standard design for those. Just debating if I want to go for BJTs versus the dual J310s, and as someone else suggested, and it's certainly been mentioned in some of the textbooks, having for the lower device a J310 and then a BJT for the upper device. So I might just put some thought into that. I do want to do some more reading about low noise circuits and just trying to produce a radio which has a very low internal noise. This one, for whatever reason, was okay, but certainly not as good as some of my previous builds. So I need to sort of go back over some of those previous builds and some of the lessons learned to work out why that may or may not have been the case. But again, one of the beauties of having a dedicated transmitter and a dedicated receiver line is then I can sort of really sort of fine tune those circuits as we go through for each side. What else? So we talked about the power amplifier, we've talked about this bandpass filter. As indicated and certainly as suggested in some of the textbooks, SSDRA for example, solid state design for the radio amateur, anything sort of lower than I think they said 20 meters, or certainly 40, there's really not a lot of need for an RF amplifier, and I will certainly vouch for that. Certainly down at 80 meters, which is traditionally quite noisy, all you're doing is just amplifying the noise and you really don't need it, but certainly very effective up in the 20 meter range. It certainly was very good. So half the time on 80 meters I just had that turned off. So for the next 80 meter build, I might for a start not include the RF amp, and then I can always include that at a later date if needed. Sorry for the pausing here. What else is worth talking about? The microphone amplifier. I'll probably look at that one. Chris was saying on that long QSO then that the the audio frequency was slightly on the higher side, so that some of the lower frequencies were being attenuated. And so on that next build I'll be having a sort of a closer look at this amplifier circuit here. When I built that and when I scoped it, when I threw in a sweeping audio frequency to the input, I thought that the frequency bandwidth was good. So I was quite happy with the coupling capacitors and the like with that. So I'm just got a sneaking suspicion it might have been a result of the passband characteristics of that filter, because it was quite tight. It certainly wasn't hi-fi, so to speak. So we'll have I'll have a closer look at that on the next build. The high power, or the audio amplifier, I'll probably keep that roughly the same. So the LM380 and the low noise op amp as a pre-driver for that. So probably just circle back around and have a look at that. I don't know if I'll look to, but potentially I may look at making that into a CNC circuit board, but we'll see what happens there. So all in all, my initial thoughts was to, as I said in sort of the very first video, was to make this a keeper. I guess my thoughts have changed over the build, and sort of looking at, I've got here 1, 2, 3, 4, 5, 6, 7, 8, 9 relays. And it's certainly very entertaining when you key. I don't want to say the whole thing moves, but it's pretty close to moving, so it'd be quite nice to sort of not to have so many relays on the next build. But certainly in terms of what I wanted to personally get out of it, which was to understand more around AGC and how that works, I certainly wanted to learn more about the initial design and how push-pull amplifiers work. Certainly got a lot of knowledge there. So all in all, and to a certain extent also with the crystal filter here, noting that I did a sort of a quick and dirty on that one. While the crystals themselves were matched quite well, there wasn't really any attempt to use some of the specialist software to design and to identify the various capacitors for that. So that in itself was interesting. So that was again another learning experience there. Quite happy, in fact very happy with a very simple over the back there, if you can sort of see it. Probably just hiding behind there. Very simple power pickoff. So the orange wire there going through the toroid is taking the RF out to the antenna, and then just a 10-turn secondary on a FT37-43, and then just a very simple 4148 diode rectifying that. In this particular case, because I've got significantly more power than the earlier radio, a 105, so 1 meg variable resistor there, just to knock back that voltage to drive this. So on transmit, this relay here toggles over, and that DC voltage there is then driving this. So just a matter of using that trim pot there to calibrate the display, and I was actually using the blue display there, and I had that calibrated to match what I was seeing up on the antenna matcher. So that will certainly be tidied up and used in the next build for sure. Right, so I'm going to leave it there. Again, for me, like I say, and I don't want to sort of sound like a crack record, it was a good learning experience, and there's certainly aspects I do want to take into that dedicated transmitter receiver radio for the next build. And we'll start that in a few weeks. I've got a couple of business trips coming up, so we will start to put some thought into that. And please let me know in the notes how you might like to see that sort of progressing. Was it useful having the paper notes? Would you prefer to see more LT Spice? Because certainly that plays an important part and a useful part. And what I think I might do for the next radio is potentially look at a more, well, we'll see, negative feedback on some of the amplifiers. But again, being a mono band radio coming up, that may not be such a big factor, because I'll just have the various amplifiers tuned for maximum performance in that particular range. So that's probably not such a big issue there. But like I say, if there's anything which requires some clarification or a different way of sort of portraying it, then please sing out. Again, for me, the reason why I'm putting up the videos is to essentially sort of say, if I can do it, then really anybody can. I am no expert in any way, shape or form in any of this. For me, it's about sort of trial and error and see how we get on. And if I can sort of encourage others to give it a go, then I've succeeded. I personally get a lot of enjoyment from using these sorts of radios, well, and at least building them and getting them on the air. For me, that's what it's all about. So there you go. Okay, again, 73s, and we, like I say, leave some notes. I'll endeavour to answer those. Look out for a couple of vids on software. We'll put those up just to sort of do a little bit more on that, and we'll go from there. Probably enough said. Again, 73s, and we shall see you next time.